Okay, let's just continue working with this one now. So I asked you to think about how you could get everything over to one side, so you could set equal to 0. And the answer is, of course, to expand and simplify. So we're going to take it piece by piece, work with one side at a time here. So we got 2 bracket x plus 4 all squared minus 5. So just working through the algebra here, it's 2 times x plus 4 times x plus 4 minus 5. Okay, and the right side here, x plus 4 times 3x minus 1, we can put that into an array and expand it. Okay, so unless I made any mistakes there, this array, these two binomials expand to 3x squared plus 11x minus 4. Okay, and on the right side here, I still have to expand out this x plus 4. Okay, so I get x squared plus 8x plus 16. That minus 5 is still sticking around. And again, just try and get to a point where I can start collecting like terms and I move things over from one side to the other to simplify. I'm not at that point yet. I still have to finish expanding over here. So distributing that 2 through the bracket on the left side, I get 2x squared plus 16x plus 32 minus 5 equals, and then I still have the 3x squared plus 11x minus 4. Okay, so just taking that last little step here and simplifying this left side a little bit more, because the 32 minus 5 gives me 27 there. Okay, I'm now at the point where I can start really grouping things together and collecting like terms. So you get to choose, okay? Remember, you're trying to get everything over to one side, so it's 0 on the other side. You can move everything over to the right side, or you can move everything over to the left side. What I'm going to, again, it won't affect your final answer. What will affect is just whether certain coefficients are negative or not. But again, when you go through the steps of actually solving using the quadratic formula, it will not affect your final answer at all. Just to make my life easier though, because I don't like having leading values being negative, I see I have positive 3x squared here and positive 2x squared here. I'm going to try and shift everything over to the right side of the equation, so I'm only going to have, so I'll have a positive x squared. So I'm going to subtract 2x squared from both sides of the equation. Okay, and again, I'm going to take this in slow motion here. If you want to skip some steps and get to the final answer a little bit quicker, you absolutely can. So 3x squared minus 2x squared is 1x squared. Okay, and I just keep going. So subtract 16x from both sides of the equation. Okay, and then again, just to finish it off, subtract 27. Okay, so you have it in standard form on one side, 0 on the other side. If it factors, that would be great. Unfortunately, this one does not factor. You can try it, but you'll see that nothing will multiply negative 31 and to negative 5. 31 is prime. So you're going to use quadratic formula here. So x will be equal to negative 5 plus or minus square root of negative 5 all squared minus 4. A is 1 in this case, C is negative 31, all over 2a, which is 2 times 1. Okay, and you just simplify. Okay, so I get 5 plus or minus square root of 149 over 2. Okay, so, and again, two possible answers from here. X is 5 plus root 149 all over 2, and x is 5 minus root 149 over 2. So I'm going to leave it to you to check to make sure you can get the right decimal answers. Okay, or you can leave them exact on a test, that's fine as well. So you should get, if you're going to round to two decimal places, 8.60 and negative 3.60 as your final answers. Okay, now just to confirm that this is correct, let's go and use Desmos. So remember, our original equation was to solve f of x equals g of x, which is this equation equals this equation. So you're looking for those points of intersection. Going to take a look at the graph here on Desmos. You'll see I have graphed both f of x and g of x. And you see there's one point of intersection here between them, and you see the x value is negative 3.60 approximately. And the other one, you have to go a little bit higher to get to it, but you'll see eventually it happens there at x equals 8.6. And it's a little bit hard to see because they're overlapping a lot at that point, but they are intersecting there at 8.60 as well. Okay, so that's it, that's all. Again, practice, as always. There's some questions there to work through, so a mix of word problems and just practicing the quadratic formula, and work through it. Let me know if you have any questions. Okay, that's it, that's all.